Continuing on with our study of Chapter 10, which is a geometry chapter, and these are usable items in understanding how our earth measure works. So section 10.3 is polygons, which are closed shapes with vertices, perimeter, and tessellations, and that's a repeated design. So I have a picture here of parcels of land, and what you can tell is the boundary lines in a rectangular format of what's available for sale. So these are polygons. And what they have are connected segments that intersect only at their endpoints. So the segments are right here, and they connect with a segment, a line that connects them. So we're going to talk about formulas and some critical thinking. So let's look at polygons and perimeter. Perimeter, like in the military, when they walk a perimeter, it means the edges, but it's the measurement of the edges. Whereas a polygon is any closed shape in a plane, that means a two-dimensional, formed by three or more segments that intersect at their endpoints. All right, so a regular polygon has all sides that are all the same length, regular, all the same length, and angles that are all the same measure. Perimeter is the sum of the sides, and it gives us length. So that is a perimeter, sum of the sides. And it carries the name of the units. And in this case, we're talking about inches, feet, meters, etc. Linear measurements. Well, under regular polygons, we have these names. And these are recognition of design of these shapes. A triangle, three sides. It's a triangle, three sides. And you can see what they are. A quadrilateral, quad, like quarters, four sides. We know them as rectangles, squares, parallelograms, those type of things. Five sides, a pentagon, just like where our intelligence organizations exist in our government is a pentagon. A hexagon is six sides, and each one has endpoints of each of the segments, and we have six sides. Heptagon is seven sides, and octagon is eight. Now, all of these shapes are polygons. Now, as to the quadrilaterals, we have subgroupings. And these describe the appearance of a four-sided polygon. So we have a parallelogram. Notice that we have opposite angles equal, and the opposite sides are equal. So we have two sides of opposite angles having the same measure, and opposite sides having the same measure. A rhombus is a parallelogram that all sides have equal lengths. All right. Then we have a rectangle, and this is like a shoebox. All shoeboxes are rectangles. And then we have a square, all sides equal. And again, all of these have parallel lines. And a trapezoid has one set of parallel lines and four sides. Now we're going to do an example. We're going to use the number of sides to name the polygon. So we're going to count them. 1, 2, 3, 4, 5, 6. 6 sides. So this is a hexagram. And we can see that up here. Hexagon. I should say gon, not gram. Sorry about that. Because it's a polygon. Now we're going to count this one. 1, 2, 3, 4, 5. 5 sides. It's a pentagon. Penta meaning 5. Now, which of these quadrilaterals, four-sided shapes, have opposite sides that are parallel? Name the quadrilaterals. Well, the square. 2 sets of parallel lines. A parallelogram. 2 sets of parallel lines. Actually, segments. Trapezoid. Only 1 set. Parallel lines. So this one is not. The opposite sides are parallel. A rectangle. Definitely 2 sets of parallel lines. We have this is the rhombus. 2 sets of parallel lines. All right. So we only had one that had one. Now we want the perimeter. Now remember, perimeter is a sum of all sides. And on this one, on a rectangle, we even have the fact that they're parallel lines. We can state that the perimeter is twice the length plus twice the width. So I'm going to have, and it doesn't matter which is which, 2 times is 6 plus 2 times the 3. This gives me 12 and 6. So I get 18, and then we have to state the units, centimeters, linear. Find the perimeter of the parallelogram. Again, we have the perimeter is going to be the sum of the sides. Well, I have 2 times that 16 plus 2 times the 7. This is 32 and 14, so it looks like 46 centimeters is the perimeter. Nothing hard. Nothing. We want the perimeter of a square. Now here, the square notation means all sides equal. So we have a quadrilateral, so it's 4 times the side equals a perimeter. So then I would have 280 inches is the perimeter. Now this one uses the word regular pentagon. So that means all sides equal, as well as all angles equal. So we can say 5 times 2, 10 millimeters is the perimeter. Now we approach a new postulate regarding the sum of the angles that are not a triangle. So supposing, and we need to put this in our notes, the sum of the measures of the angles of a polygon are a little formula. The sides minus 2 times the 180 degrees. So let's prove it, okay? Let's prove it with a rectangle. So we want the measure of the angles. A rectangle has 4 90-degree angles. So we have 4 times the 90. And that would give us 360 degrees. Okay, this is by definition. Let's use the formula. Okay, a rectangle has 4 sides, so it is 4 times 2 times the 180. So this is 2 times the 180 degrees, and that gives us 360 degrees. So we can see that that formula is good. Now, an example of the rule. Find the sum of the measure of an angle with a 10-sided polygon. 10-sided polygon. Okay, so my N is 10 sides. And we want sum of angles. And it doesn't matter which or which. We know that we're going to have 10 minus the 2 times the 180 degrees. 8 times 180 degrees. And that gives us, and we're going to do the calculator because that's a little bit bigger than I can handle. So we're going to do the 8 times the 180, and we get 1,000, sorry about that, 1,440 degrees is the sum of all angles in a 10-sided polygon. All right. Nothing hard. Now, find the sum of the angle measures of a nonagon. Nonagon. I got this from the internet. A nonagon or n-nonagon is a 9-sided polygon, a 9gon. The name nonagon is a prefix hybrid formation from Latin nonus, ninth, or gonon, used equivalently, attested already in the 16th century in French nonagon and in English from the 17th century. The name enenagon comes from Greek enenagon, 9 plus whatever this is, and is arguably more correct, though less common. All right, so we have a 9-sided polygon. So we know that n equals 9. So we want the measure of the sum of the angles. So we're going to say 9 minus the 2 times the 180 degrees. That's 7 times the 180 degrees. And then we're going to use our calculator. So here we go. 7 times the 180. And I get 1,260. All right. Now here is our last problem, and it's not difficult. This section is just an exposure about what you can figure out. All right. So find the sum of the measure of the angles for the figure given. All right. So we want the sum. Even though some are given. So we're going to count the sides. Here we go. So I have 1, 2, 3, 4, 5. We have a pentagon. So n equals 5. So now we're going to do the formula. N minus 2 times that 180 degrees to find the total, the sum of the angles. So here we go. 5 minus 2 times at 180 degrees, 3 times the 180 degrees. So here we go. And let me get my calculator. 3 times the 180. And I get 540. All right. The total is 540 degrees is the sum of all angles and in the pentagon. All right. Now we could have, now they want us to find the measure of A and B. All right. B. Find measure. All right. So we can do A first. We know that we have 90 degrees here because they're right angles. And we know the total. So we're going to use that 540 degrees has to equal the 170 degrees plus the 20 degrees plus 90 degrees plus 90 degrees plus the measure of angle A. So we're going to add these guys up. So we're going to do the 170 plus the 20 plus 90 plus 90, and I get 370 plus the measure of angle A. Now I'm going to subtract that 370 degrees from that 540. When I do that, then I have the measure of angle A. And I'm going to verify with my calculator in case I've made a math error, which would be embarrassing, but it happens. And I didn't, so we're good. 170 degrees. So we have the measure of A. Now we're going to find the measure of B. So we know that the measure of angle B plus the measure of angle A equals 180 degrees because they are supplementary. To be exact, they are adjacent angles that create a straight angle. A straight angle is 180 degrees. So we have this right there. So then I know that the measure of angle B plus the substitution for angle A has to equal 180 degrees, right? So I'm going to subtract the 170. Now remember, the picture's not drawn to scale because you're going to say, excuse me, that doesn't look like a 10 degree. But the 20 degree is disproportionate as well. So we have angle B, we have angle A, and we're done with this lesson. Now do the homework. Thank you so much for listening.